Good afternoon, everyone. Again, I'm Carly Morgan. And before I introduce our presenter today, I wanted to give you a little information on the format. First, all of your lines are muted. And if you would like to ask a question, there are a couple of ways to do that even though you are muted. The first, you'll notice on the control panel that there is a little hand, a box with a little hand on it that has an arrow pointing up. That's a way to raise your hand to let us know that you'd like to ask something. Additionally, you have a chat box down at the bottom of the control panel which you can type a message to send to us. Also note that you can choose who you're sending it to in the drop-down menu below that. You can choose it to send it just to the organizers, to the whole group. You can decide that. If you're calling in, as opposed to being on a computer, you won't be able to exercise either of those functions. So we will have specific times where we'll announce that we're unmuting the lines, and you will be able to ask your question then. However, because we're going to be unmuting all of the lines, we'd ask that you keep your phone on mute as well. So if there is background noise at your end and you're not asking a question, you're able to keep the noise down on the webinar itself. Dr. Principe will take breaks at natural pauses in her presentation, and we'll go through questions that have been submitted at that time. And if there's time at the end, we'll also open it up for any additional questions as well. With that, I'd like to introduce our presenter, who is Dr. Gabrielle Principe. She is the chair of the Department of Psychology at the College of Charleston, where she studies cognitive development in young children. Her research has been funded by the NIH, and she's been published in a number of scientific journals, as well as having written a book, Your Brain on Childhood, The Unexpected Side Effects of Classrooms, Ballparks, Family Rooms, and the Minivan, which will be a great resource for extended information on the topic we're going to address today. Additionally, she is also the education section editor for Evolution Institute's online magazine, Evolution, This View of Life. So look out for her there as well. With that, I'm going to go ahead and turn it over to Dr. Principe to get started.
Great. Carly, thanks so much for that introduction, and thanks for everyone for being here. Let me start out by telling you all a bit about what I'd like to do in the next bit of time we have together. And really what I'd like to do is to try to present my talk in 4 different parts and pause after each part to see if there are any questions. But I'd like to start out by talking about why it's even an interesting conversation to begin to look down on education from an evolutionary perspective, and then move on to talk a bit about how it is that we, and particularly children, have been designed by evolution to learn. Then I'd like to move to a discussion of talking about things that we do, things that if you look at our species in evolutionary time that are evolutionarily novel, that tend to be not so great for children's natural curiosity and love of learning. And then in the last few minutes, if we have time, what I'd really like to do is to have a discussion about ways that we can rethink the ways that we educate children in particular in ways that gel with how our brains have evolved to learn. So that's where I'd like to go. Where I'd like to start off is by asking you all to take a look at this picture. It should look familiar. It could be really a snapshot from almost any American classroom. Now, if you were to ask, say, the boy who's there in the front row what he does in school all day, he probably won't tell you that he spends most of his day collaborating with mixed-age peers on meaningful tasks that are immediately relevant to his survival, right? He'd probably tell you the same thing that almost any American school child would tell you, that he spends more time preparing for standardized tests than the typical hunter-gatherer of his age, that he's more likely than the usual young nomad to be assigned math and word study worksheets for homework, that he belongs to the only hominid species whose young are asked to memorize times tables and state capitals, And clearly you can see for yourself that he does most of his learning in a physical environment that's very different from that of most primates. Now, I hope at this point this little exercise makes clear that when you look at education in an evolutionary or deep time historical context, it becomes clear that children today are reared and educated really in a radical different way than they used to be. And the reason that I think this is worth discussion is because, well, the context in which we rear and educate children have changed, but their brains have not. Today's children come into the world with the very same brains and accompanying tendencies, abilities, and adaptations as their nomadic hunter-gatherer peers dating back at least 35,000, but perhaps as far back as 250,000 years. And what's more is that many parts of their brains have originated even way deeper in their evolutionary path long before things like language, deliberate thought, thumbs, or creatures, animals like us even ever existed. So what does this mean? Well, one thing that it means is that the brains inside children's heads were not designed for life in the modern world. They were not designed to spend their days inside a classroom, reciting times tables, memorizing state capitals, filling out workbooks, taking standardized assessments. Rather, they evolved in a very different world. Now, with that in mind, my goal for today is to think about the implications of this recognition of our brain's long evolutionary history to the educational process. When you look at education in this way through an evolutionary lens, you begin to see that formal education and much of the skills that we attempt to teach children in school, like reading and writing and most of modern day mathematics, really are recent phenomena in our history. How recent? Like very recent. So if we play this out, the very first humans or first members of the Homo genus emerged roughly 2 million years ago. Our species, Homo sapiens, evolved roughly 250,000 years ago. Now, in contrast, the invention of, say, written language and numbers occurred only a few thousand years ago, and it's only been within the last several hundred years at most, and of course not yet universally, that formal education has been a requirement for children's success in the world. That's less than 1/100th of 1% of the human brain's entire existence. Truly in evolutionary time, that's just a blink of an eye. So by the standards of evolution, there simply has not been enough time for natural selection to have adapted the young brain to the conditions and the challenges of modern education. The bulk of our brains evolved before there were any of these things, before there were books or grades or school or smart boards. And of course, children can deal with these things, indicating that evolution has given them a brain that is adaptable to unfamiliar environments and novel tasks. But I think this recognition of our deep evolutionary history also means that children's brains evolved to be educated in a different way. And I think it's exactly why our system of education, with its emphasis on learning in the classroom, pre-planned curricula, rote memorization, and standardized assessment, in some children is having unwanted side effects. Now, how can something designed to make life better, to improve life, like school, have unwanted side effects? Well, lots of modern inventions do this, like the chair. So it, like school, is a recent invention designed to improve our lives, right? It's a great thing to have. Because of it, we don't have to watch webinars like this standing up. If we want to, we can sit down on something like this. We can use this to, watch TV, eat dinner, hang out with friends, check out our iPhones. But the truth is, this really comfortable invention has led to some very uncomfortable side effects, namely hemorrhoids, right? So think of it this way. Evolution has given us a couple of pretty neat design features that help our veins get blood back up to our heart, which really come in handy for places at the bottom of our bodies, like our feet, because the blood has to travel against gravity uphill to get back in our heart. So one neat design feature is a series of valves that allow blood up but don't allow the blood to move back down. Another is that when we move around, muscles in our legs contract that work to pump blood up the veins in our legs. This setup works awesomely in animals that move around a lot, which really is exactly what we've done for most of our evolutionary history. We went from active tree-living primates to active hunter-gatherers as early humans to active agriculturalists as we settle down, but now we sit down a lot. And because of all of this sitting down, sometimes there are not enough contractions to pump all of the blood back up our veins. And when this happens, you know what happens. Blood pools in the veins, valves fail, and we end up with increasingly swollen veins that literally can be a pain in the butt. So the chair is an uncomfortable reminder that we were simply not built to sit around. So just as sitting around for long periods of time is a foreign element in our natural ecology and can have unwanted side effects, so is schooling a foreign element in the natural ecology of childhood. And I think this can explain why then some children hate school, why many children have trouble with it, and why some really just don't seem to enjoy it. And of course, there are many reasons for variability in children's school environment, genetics, their home environment, so on and so forth. But part of the problem is really the very nature of school and the contrasting nature of children's brains. It's this disconnect between children's evolutionary past and their novel present that makes parts of modern schooling challenging. I think, however, the good news is that the better that we understand the history of the brain, I think the better able we are to prepare children to succeed and live well. So to see why, let's backtrack for a minute and do a quick history lesson. So when our kind first appeared on the scene about 2 or so million years ago, life was very different than today, right? Families lived in small nomadic bands. They made their living essentially hunting and gathering. Childhood was very different than it is now. Children spent their days roaming in packs and playing on their own in the out of doors. And education was certainly different. It was informal, and new skills were learned by getting your hands dirty in a hands-on manner at the hands of more skilled peers and adults. Children learn new skills on the job as they collaborated with multi-age peers on tasks that were meaningful to everyday life. So new skills were taught, not in a classroom, but rather in the very context in which they were practiced. And the reasons for learning new skills were always apparent. So, for example, adults didn't show children how to identify edible plants so they could demonstrate that knowledge on a biology exam. Rather, children learned the skills so they could forage safely for lunch. And truly, such was life for 99% of our species' existence. Then, about 10,000 years ago, things changed. We gave up our nomadic hunting and gathering ways. We settled down, we established stationary communities, and we domesticated plants and animals. The thing is, that's most relevant to this discussion, is that maintaining this new sedentary and farm-based lifestyle from one generation to the next depended on a certain amount of technological know-how being transmitted to kids. And at first, much of this education was still done the way it had always been done, on the job. But as the tools and technological skills needed to thrive in adulthood ratcheted up in complexity over time, out of context instruction emerged. Now, today, formal education it's necessary for our children's success, but the newness of this practice really can't be understated. Humans evolved some 2 or so million years ago, yet it's only been within the last few hundred years that formal schooling has become part of the ecology of childhood. Now, if we're to play our ancestors and think about how education would look to I don't know, our hunter-gatherer peers way back in the day, modern education would look silly to them. It would look unrecognizable. But the thing is, today's children come into the world with the very same brains as our hunter-gatherer ancestors, yet we sit them down in classrooms. We give them textbooks and we ask them to take standardized exams. We ask them to learn things that their brains never expected and in contexts that are absolutely foreign. We expect all children to learn the same set of skills at exactly the same rate. There's not much room at all for individual differences in learning speed or for following one's penchants beyond the state's curriculum. Clearly, the classroom presents a formidable challenge to the brain's educability. It's an evolutionary novelty that seems to have caught a lot of children off guard, as opposed to the real world learning that we've done for most of our history and that arguably the brain was designed to do. Most of formal education today takes place out of context, inside a school building. We pull children out of the real world for 8 hours a day and we sit them down in a classroom with same-age peers and with unfamiliar adults. We ask them to learn for learning's sake, not to solve problems immediately relevant to their lives. They multiply by 2s, by 5s, by 10s. They sort vocabulary words by vowel patterns. They memorize facts about the American Revolution. Some can identify layers of the earth, and some can even distinguish between kinetic potential and kinetic energy. That's awesome. But they do this all for reasons likely not clear to any or many of them and absolutely unrelated to their lives outside of the classroom. I'm a mother, and I've truly lost count of the number of times that my children have said things like this to me, like, "Mom, why do I need to memorize all of the state capitals when I can just Google them on my phone? Can you even name them all, Mom?" Right? But I doubt the same kind of conversation went on in families 10,000 years ago. You know, "Mom, why do I need to learn to grind a stone axe?" It's clear why. So I think this super short history reveals why formal schooling presents a formidable challenge to the young brain. We know that our brain has not changed that much over 250,000 years, and really certainly little at all over the past 35,000 years ago. We know that formal education has existed for only an evolutionary blink of an eye. What this time frame means is that there simply hasn't been enough time for the brain to adjust. Children's brains didn't evolve to deal with formal learning, yet we sit them down in classrooms, we lecture to them or at them, we assign them lists to memorize, and then we top it off by testing them with standardized exams. These are all evolutionary novelties for which children's brains were not designed, and that hundreds of millions of years of evolution truly never saw coming. Considering that formal education is an evolutionary novel experience, if you'll buy that, I think that we shouldn't be surprised that many children have difficulty with its demands. Nor really should we be surprised that many children lack the motivation for the out-of-context learning that happens in the classroom. For instance, it's likely tough for a first grader to understand why he's being asked to memorize the spelling of a bunch of unfamiliar words, then write them 4 times each, and then sort them into alphabetical order, if no one outside of the classroom makes it meaningful, if no one ever reads to him or with him. But if his family regularly reads storybooks and street signs and store marquees and cookie recipes and restaurant menus with him, then he's likely to understand not only why his teacher is asking him to learn new words, but also that reading can be good fun. So I think this evolutionary perspective on schooling suggests that we should consider ways to put children's learning back into context to make it meaningful and consequently motivate learning. So to make this more concrete, the motivation to read is really not motivated by the process itself, right? It's not driven by, oh, the thrill of sounding out isolated words or spelling them correctly or coming up with synonyms. And you know this already. If you've ever tried to get your child or your student to do a word study worksheet or had to bribe them to, write out definitions once again for this week's vocabulary words, right? The motivation for figuring out what those words mean and how to use them is driven by being able to do meaningful things with them, like reading stories, writing messages, leaving notes, understanding signs, making out recipes, or sending text or posting on social media. The same can be said for other subjects like math. The motivation for learning math really doesn't come at all from the excitement of rote counting or estimating whether 2 plus 2 is more than 10, identifying different shapes, or certainly solving long division equations, right? It's driven by what you get out of that. It's driven by the real world benefits of, being able to figure out whether or not you, as a 6-year-old, have enough money to buy both the action figure and the spaceship, or whether or not you can divvy up your jelly beans equally among all of your friends, or whether or not you have the wherewithal to estimate how many bags of sand you might need for that nifty new sandbox. Now, there certainly are increasing formal curricula aimed at applying learning to real-world situations, but the thing is, they're often still centered in a workbook or on a computer or tablet that goes on a desk that's inside a classroom, inside a school building. My question is, how can we expect children to go out in the real world, outside of the classroom, and solve its problems if we confine them to a classroom for the majority of their education? Imagine if your doctor never saw a patient until after he had spent 8 years inside a classroom learning about patients. Or if your car mechanic had only read books about engines and performed pencil and paper standardized assessments about engines. And the same goes for anybody, your plumber, your hairdresser, your child's piano teacher. So I think teachers and parents need to move some of the learning out of the classroom and into the real world. Otherwise, it's really no different than, say, sitting a blue jay down inside a classroom with a bunch of his bird peers, giving them all a textbook on nest building, asking them to memorize types of suitable nest construction materials, then maybe showing them a documentary on nest weaving techniques, and maybe then, to top it off, having them work out their nest building plans in a workbook and then letting them go. That seems completely silly. All right, so let me stop there. I'll switch gears in a second and see if there are any questions.
Hi, this is Carly again. So I don't see any hands raised or any messages sent by chat. So I'm going to open the line, meaning I'm going to unmute everyone. I would ask that if you are going to ask a question that you identify yourself, please, and then ask your question. As well, if you're not asking a question or you know that you have background noise, ambient noise that could interfere with everyone else hearing, that you mute your line individually. And here we go. I'll take everyone off of mute. Okay, so we can hear everyone now. If anyone has a question, feel free to go ahead and ask.
I can ask a question. This is David Wilson. Can you hear me?
Yeah, hi, David.
Hey, Gabe. Could you comment? One question I have is, how could anyone learn under these circumstances? We all have Stone Age brains, but in fact, some of us do learn under these circumstances. So can you comment on why it is that this works for anybody?
Yeah, so David, so some of the things that I want to talk about in just a bit are just that, or maybe some ideas about how to do it. So certainly I'm making the case that we have these ancient brains in a new world. But what I want to talk about in a bit is ways that I think that evolution has designed us to learn, and that maybe we could do education better, particularly for younger children, if we try to educate them and try to get consistent with the way that time has been taught traditionally. So can I put that question on hold a bit, and if I don't answer it in a bit, we can come back to it?
Of course.
Awesome.
Okay, anyone else that has a question they'd like to ask? If not, we will go ahead and move on to the next section. Okay, then I'm going to go ahead and put us all back on mute. Gabby, we'll turn it back to you.
Perspective, but it's more so really just coming from a vanilla developmentalist perspective. So these ideas that I want to share on how children are built to learn, truly aren't controversial. If you have a developmentalist membership card in your wallet, we're all saying the same thing. But I think it's interesting to think about this and maybe look at it through an evolutionary lens. So let me kind of work through this a bit. So most developmentalists like to liken our natural style of learning to that of a scientist, that we're designed to learn about the world, to figure out how things work, really much in the same way that scientists do. So let me play this out a bit, and I think it's kind of necessary to do that, to get you all to think through it and whether or not you buy it, and then to think through what the implications of this framework might be for education. So,
Gabby, can I interrupt you for just 1 second? I apologize. So a question came in from Brandon Hendrickson that was right at the end that I didn't get to. So if you don't mind, I'll interrupt you for just a second to go back to the original section. So he says, thanks for all of this, Dr. Principe. Is there a danger in throwing out the baby with the bathwater when we focus on the evolutionary mismatch between the mind and the classroom? I'm thinking particularly of the progressivist effort to remove what has been a rich humanities curriculum from schooling.
Yeah, I think that I think there is always a danger in throwing out the baby with the bathwater. I think that one of the goals when I give talks like this is to hopefully incite people who are researchers to kind of begin to do some learning research under this umbrella. So I think that a lot of the things that if you could see me, you'd see me standing on a soapbox right now. The things that I'm standing on my soapbox about and trying to talk about truly are things that need much, much more research. So I know it sounds like I'm on my soapbox saying let's just throw the baby out with the bathwater, but I'm kind of more asking you to think about this perspective and think about whether it's worth doing that. It might not be, but it might be, and that's indeed why I think it's kind of worth having this conversation. So so that's kind of where I am, and maybe that's another question that we can kind of come back to at the end as well too, if that's okay.
Thanks, Gabby. I think we can go back. Sorry for the interruption.
No, it's all good. Okay, so let me play out this story about how it is that developmentalists think that children learn like scientists. And certainly to some of you this isn't new, but I think it's a good place to kind of insert this, this kind of framework. So the thinking is something like this. The thinking is that we essentially come into the world day one, begin our program of research. So during the first year of life, infants center this program on really beginning to understand the physical properties of things. And they use their entire set of senses to actively test and systematically analyze the world. So babies spend their days just kind of hanging out, making observations with their senses by squeezing things, by pushing things over, by tearing things apart, by banging things into one another, I don't know, by dipping things into the dog's water bowl, by dumping containers all full of things onto the floor, by sticking things in their mouth, and even, giving things to other people to stick it in their mouth, right? And often this means, like a lot of scientists, their laboratories are messy, and sometimes things get broken. So once babies have kind of sat back and observed the world for a bit, or if you want to play scientist, once they've collected sufficient pilot data, babies begin to design specific experiments to learn about things. So for example, what happens if I let go of my mom's coffee mug? Will it fall down or up? If I hide my mom's car keys underneath this pile of dirty socks, will those car keys cease to exist? Right? And then as infants' program of research progresses, their experiments become increasingly sophisticated. So if I drop mom's sunglasses on the floor, will they bounce? If I throw them up in the air, how high will they go? If I throw them with more force, will they go higher? Will they go faster? Will they go through the ceiling? From the observations that come from these experiments, children then, like any good scientist, then form specific hypotheses about the world, design experiments and carry them out to answer their research questions and draw conclusions from their data. So yesterday when I threw mom's sunglasses down the stairs, both lenses cracked. I hypothesize that the same thing will happen today if I throw dad's sunglasses down the stairs. The thing is, when the data don't pan out as expected, which happens to all of us scientists, children do the same thing that we do. Children self-correct, they revise old hypotheses, and they go right back into the lab for additional experimentation. So mom's coffee cup did not bounce when I dropped it onto the hardwood floor. Perhaps it will bounce if I stand up on the kitchen counter and drop it. So their laboratory manner, like a lot of scientists, is aggressive, inspiring, and maddeningly persistent. And this is exactly how developmentalists think that infants learn about things like drop-offs, gravity, that solid objects can't pass through one another, that when, I don't know, mom stands behind the kitchen counter, the bottom half of her doesn't cease to exist, right? These are skills that we don't teach kids. You don't sit down a 1-year-old and talk about gravity. Rather, children learn these things through experimenting and watching the world themselves. When infants move into their second year, the thinking is that they extend this sort of experimental approach to the social world to figure out people. So they may put together a hypothesis like, if I put blue finger paint all over the dog, will mom get mad? And like any good scientist, they often tweak their methods to examine their research topics programmatically. Will wet red paint on the dog also get mom mad? How about if I put it on the guinea pig? Or how about if I put it on my baby brother? So they broaden their work also to different populations to see if their results generalize to new populations. So will finger painting the pets in my brother also make dad angry? And like good scientists, they replicate their experiments to be sure that their findings are stable. I'm going to finger paint the dog just one more time to make sure that that still makes mom mad. So through this experimental self-correcting way of learning about things, children learn about how people are different from one another and how they're different from themselves. They learn that dad really doesn't want a pretty pony set for his birthday, and that mom really doesn't enjoy the feel of Jell-O being smashed between her fingers. So this experimental style of learning is the way that we come into the world, and the way that we've been naturally designed to learn, and the way that we've been doing it since before our days living as nomads in the grasslands of Africa. It's an active and experimental learning style that we have not outgrown. So a question to ask at this point is, well, what drives this? What drives children to discover, experiment on, and explore their world? Well, here's the answer that a lot of developmentalists have come up with, and it's that children are born with a deep desire to understand the world and an incessant curiosity that compels them to aggressively explore it. And you can see this easily for yourself in the youngest of our species. They're constantly experimenting, asking really just extraordinary questions about ordinary things, and so much is still new. So they're constantly seeking to understand and master everything in their world. It's truly why they're such a mess, why they dip their hands into the birthday cake that you just finished icing. It's why they skip through rather than around that muddy puddle, and it's why they take forever to walk between the front porch and the minivan. The 20 feet between your house and the van door is truly their field laboratory, and it's full of all sorts of natural phenomena that demand immediate study. So children are driven to explore their world because new discoveries bring them joy. The learner's high then compels them back out into the world so they can make more discoveries and experience more joy. It's truly a straight up reward cycle that, if allowed to thrive, will persist a lifetime. As children become, and their learning becomes more sophisticated with age, learning brings them not only joy, but also mastery. Mastery is what gives them the capacity to take intellectual risks in their domain of expertise, to make the next smart car, the next wonder drug, or the next thing. But as I'll talk about in a bit in the next section, it's possible to break this natural cycle, to squelch children's drive to explore and to seep the joy out of learning. Now, this childhood drive for exploration is so strong that many scientists consider it a universal human drive, just like hunger, thirst, and sex are drives. Now, when I say this often, I get like what are you talking about? And this is sort of a typical question. So if children are driven to learn, like they are driven to eat and drink, then why is it nearly impossible to get Junior to do his homework, but I've never had to force feed him a bag of cheese curls and a juice box or whatever? The answer is this. It's because much of the sorts of learning that we ask him to do don't satisfy his drive to actively explore and experiment on the world. So memorizing the life cycle of a grasshopper, reading about the physical properties of a paperclip, or mapping the major battles of the Revolutionary War so that he can pass the 4th grade doesn't satisfy his drive to learn and explore any more than a cardboard hamburger or an imaginary milkshake would satisfy your drive to eat and drink. No matter how much we make children watch educational videos, sort vocabulary words, do math exercises, or lecture at them, just like I'm doing right now, their experimental style of learning is something that they won't outgrow during their school years. Their brains were built for a different kind of learning. They're compelled to take on the world as their laboratory so they can master new things, not spend their days with flashcards and word sorts preparing for the next exam. This disconnect between children's brains and the ways in which we ask them to learn really, I think, is why many children rarely find joy in learning. And I think it's why it's tough to motivate so many children to do well. So what I want to do is, I'll stop here for questions again, and what I'm going to move on to talk about next is, I think, things that we do in the modern world that can kind of squelch this drive to learn. But let me take a break and see if there are any questions at this point.
Okay, then we will unmute the lines again, and feel free to ask any question you have, and please identify yourself, as well as use your own mute function if you know that there is background noise. Here we go. Okay, anyone have a question?
This is Jerry Miller. Gabrielle, can you talk a little bit about, you've been focusing a lot on the cognitive styles of learning or types of learning. Can you talk about the social and the emotional types of learning that take place and how that relates to what you're referring to?
Yeah, absolutely. So, and I'll just answer it in one way. I think there's lots of ways to answer it. So one of the learning contexts that I'm not going to talk about that much today is play, is children's play. So I think for a lot of developmentalists, when we're thinking about social skills and emotional skills that are important for children to figure out, to learn early on in life, one context where those skills develop, I think, and a lot of developmentalists think really strongly, are through play and in play. And that play really has some kind of secret sauce that makes that a place where these skills are learned. And it's largely because in free play, kids are on their own. They have to regulate their own behaviors, their own emotions. They have to make their own rules. They have to figure out who's breaking rules. And it's a very motivating and demanding context like no other, because it feels good to be in the middle of it, but you have to regulate yourself in all sorts of ways in order to continue to be invited along. So Jerry, I mean, you're right on. I'm kind of focusing on the intellectual things that come out of school. And I think it's a bit of a different discussion to talk about social emotional things. But that's absolutely a part of this discussion. It should be in there.
If I could follow up a second, the idea about learning how to self-regulate,
Right.
what is the research showing? Is it that kids can learn more effectively self-regulation playing with peers, or is it with peers and adults, or is it imposed by adults? I mean, typically adults impose it.
So Jerry, I think, in my view, it's a large literature that's messy because it's so large. But one of the interesting themes in that literature, well, it depends on the age too. So for younger kids, part of what they have to figure out how to do is how to play. And so older children and adults can certainly facilitate the learning of how to do that. But there's also some pretty interesting evidence that the sophistication of play changes when adults are present. And there's also some kind of cool outdoor stuff that demonstrates that when children are even outdoors with adults, that even really simple things, like when children are outdoors with adults, they tend to walk more in straight lines, where they're left to their own devices, they tend to take longer to get places, but they spend more time exploring. So it's truly a messy literature, and but it's interesting, certainly to think about. But I do think that emotional that play is certainly a context that can facilitate the development of emotional regulation, for sure.
We've had another question submitted by chat. Marcel Harmon asked, what does your research say relative to introverted versus extroverted children in terms of preferred strategies for learning and the environments most suited for each?
That's a really good question, and frankly, I don't know how to answer it. So I don't know that research at all. But one of the things I want to talk about in a bit really is the ways in which, the way that we educate children diminishes a focus on individual differences in kids. So if I kind of blow up your question a bit, one of the things that I would say is I don't think that across the board that we are very good at paying attention to those individual differences, whether they be what you're mentioning or something else, but I think that we should, because decades of research have shown that there are a gazillion ways in which humans differ in terms of learning, cognitive abilities, and I think it's important for educators to figure out how to better pay attention to them. And like I said, I'll kind of follow up on that in a bit.
Okay, I have one other question that was submitted. Let me just, excuse me while I get back to it. I have a question. Her says, the spaces for learning have been mentioned. Are you familiar with any research specifically about school environments through the lens of evolutionary psychology?
So, no, not through the lens of evolutionary psychology, but there is. So, I mean, honestly, I don't think there's enough research. I mean, there are some studies that look at how even putting children in outdoor environments, you know, in the middle of a school day can be a good thing, even if, and particularly if, those environments are unstructured. So, I mean, there's even some studies that show if you just kind of dip children into the outdoors, give them just a taste of nature in the middle of a day, that sort of thing can be really good food for learning and attention later on. So I think there are reasons to think about physical environments, you know, with an evolutionary lens. I think that's an area that hasn't been focused on that much in terms of learning, but it's really kind of what I'm trying to encourage people to do, to take a literature that's traditionally not been evolutionarily framed, like a lot of the learning literature. But I think it's interesting when you put on an evolutionary lens and look at it. I think a lot of the research that is out there, particularly developmental research, really gels with what I think an evolutionary approach would be too. And I think that's good. I mean, I think that's super exciting when you have a literature that didn't purposely start out with this framework, but it's not inconsistent with thinking about things this way. And I think that there's benefits for thinking about things this way because I think it answers the question sometimes why. You know, why does this particular type of learning or strategy work? Well, it seems that the why is it gels really well with the way that it seems like we've been designed to learn or something like that.
Okay, we have one other question that's been submitted by chat. I'm going to go ahead and, for the sake of time, put everyone else back on mute, read the question, and have you answer it, and then we'll just move on to the next part of your presentation. And remember, if we have time at the end, we can ask additional questions if you've got a burning one about this section that we didn't get to. So I'm going to go ahead and mute everyone. Okay. Oop. Can you hear me? Yeah, you can. Okay, so here is a follow-up from Brandon Hendrickson. He says, well said, all of this. When we rightfully oppose the growing tyranny of workbook, textbook learning, I think there's a tendency for us to champion the importance of play and of hands-on learning. And as a spouse of a Montessori teacher, I'm definitely on board with both of those. What I'm wondering is if there are other evolutionary prepared possibilities of engaging kids with the real world. For example, stories and metaphors and music, mystery and awe and heroes and riddles. Beyond play and hands-on learning, any thoughts on how we can work with evolution?
That's an awesome question. So this is my reaction to that, and so my area of research is autobiographical memory, and if I think about that through an evolutionary lens and think about what memory is for, the way that it's been designed really is not for us to be good factoid rememberers, but it's been designed for us to be good storytellers, and sometimes being a good storyteller means not being completely accurate, you know, not having a completely pristine memory. So if I play that card and think about, well, what's memory for? What's it been designed for telling stories? Well, then I think, yeah, absolutely. If you think about the sorts of things in your question, yeah, those are all things we've been doing for a while, and systems have been designed for those things. I absolutely think that we should take advantage of those things. And in fact, and this is a little aside, I have a student who's working with me right now, and her her goal in life is to write a biology textbook from a storybook perspective. And I think that's great. Like I said, I think we, you know, are designed to be cool with and, you know, remember stories. And in my area, in memory, we are so much better at remembering things if they're in a narrative than if they're in a list. And the reason is kind of what I hinted at earlier, is it's meaningful. If you put facts into those sorts of contexts, they become meaningful and they become more memorable. And I think that too makes sense if you put on your evolutionary glasses and look at what our systems have been designed for. So awesome, good, Brandon. Awesome. All right, let me switch gears a bit, and the spiel that I just gave before those was sort of my story on how developmentalists think that children learn. And you know, from time to time, I'll give that spiel to parents at schools, and inevitably, I'll hear from a parent who jumps up, raises her hand, and you know, says something like, "She's sure her child must have skipped this naturally ambitious stage and went straight to underachiever." And I'll tell her I'm sure that she's wrong, and to prove that she's wrong, I'll ask her to spend some time with this kid that you see up on the screen, or really any infant who is fiercely trying to grasp a toy, or a baby who is just restlessly trying to figure out how a zipper works, or a toddler who is just trying so hard to say what's on her mind. These sorts of skills are not the ordinary sorts of skills like, you know, the times table that a second grader is trying to cultivate in math, but they are the most difficult tasks of a lifetime, learning how to walk, talk, and think. But no matter how tough the going gets, babies would never throw in the towel, complain it's too hard, or that it's not worth the effort. They don't worry about making mistakes or humiliating themselves or getting a failing grade. No matter how many times they stumble, they get up and they barge ahead, headstrong on mastering the day's mission. But then, several years later, this happens to a lot of kids. To a lot of kids, the learning fire seems to go out. What happens? What happens in between this just 1-year-old that can't get enough of the world and a 6-year-old who just tolerates school? I mean, sure, the world is not as new and exciting by the time you've been on the planet for, 10 years. But I think that the loss of motivation for learning falls squarely on our plates. School somehow seems to take a toll on the natural curiosity and enthusiasm for learning with which children began life. So what I'd like to do briefly is talk about some things, some evolutionarily novel things that we do that can, and I think have for a lot of children, squash their natural love of learning. I'm going to talk about 5 things. I'm going to talk about what I'll call drill and kill, rewarding children for learning, why telling children they're smart is not a good thing to do, why taking away recess is not a good thing to do, and why we should think twice about homework. And what I will tell you as a developmentalist, this list could have 50 things on them. But I just think these are some really interesting things to talk about, and there's some compelling science behind them. So I think it's kind of fun to talk about it. So let me talk about drill and kill. Now, as I'm sure you all know, increasingly the standards movement has been motivating teachers to teach to the test and to focus more on a drill and practice educational strategy. The style can teach new facts and lead to gains on tests, but in education circles, it's often referred to as drill and kill, right? Drill because you drill children with facts, and kill because it eventually kills motivation to learn. Not only do I worry that a focus on memorizing facts can dampen children's natural drive to learn, I think the bigger question is that asking children to memorize facts like presidents, state capitals, historical dates, whatever, has outlived its usefulness is the main thing that school is for. I mean, this isn't to say that it's not important to teach content, right? Children surely should be taught about history, but asking students to do something like my son was just asked to do, to memorize the Constitution, it sheds no real light on U.S. history, and it leaves children with no genuine skills for, see, understanding the significance of the Constitution or the role of the Supreme Court in interpreting that document. And I also think that in today's Google age, where really any fact is at our fingertips, we can find out anything in 10 seconds. We don't need school to fill children's heads with facts. We need school to teach children what to do with facts, how to think about facts, how to weigh some new fact against other facts, how to think about them critically, how to put them together in new ways to do something different, how to use them as evidence to make an argument, and how to talk about them congenially with others. Okay. Now, rewards for learning. Now, rewards, if you've taken a Psych 101 class, you know that rewards can cause desired behaviors and cause these behaviors to happen more frequently. So if you give a dog treats for rolling over, it will roll over more. You can even get squirrels to water ski if you reward them in the right way with the right time. That's why that picture is there. So it seems that rewarding children for doing their schoolwork might be a reasonable way to motivate kids to learn new things. But does rewarding children for schoolwork work? Well, it'll get them to do their work, but it will also totally seep the love of learning out of them. Why? Because learning is not driven by external rewards, but by internal motivation. As I talked about earlier, mastering new things feels good. Exercising and extending one's own knowledge is just inherently satisfying. One of the things that we know as psychologists is that anytime you reward an intrinsically motivated behavior with external incentives, like prizes or money, we begin paying more attention to the incentives and less attention to the pleasure that comes from doing the behavior. The shift in attention brings about a shift in motivation for the extrinsic incentives and ostensibly disables the existing intrinsic motivation. So when kids are rewarded for doing something they already enjoy, the reward alters their locus of motivation from internal to external. So kids come to focus on the prize and no longer are excited about learning. And there are so many demonstrations of this. If you reward toddlers for cooperating, which they do naturally, they'll do less of it if you reward them. Preschoolers love to draw. If you reward them for it, they'll later do less of it naturally. It's because they come to focus on the reward rather than the joy that comes from doing that task. And it works for adults too. If I take students in my Psych 100 class right now, if I reward half of them for putting together puzzles and just ask the other half to put together puzzles, those that I rewarded, if I bring them back to put puzzles together again, those that have been rewarded aren't going to want to do it without the reward. And the thing is, many of us promise our children these kinds of things for reading and writing and studying because we'll do more of those things if we give them these things. But in the process of giving these things for good behavior, children go from learning, because it's awesomely fun, to learning to get the gold star, the special privilege, or the grade. So the goodies rather than the drive motivate learning. And I have to say that grades are really a sore spot among us developmentalists. So, honestly, for a long time, we've been complaining that grades are the reason that so many students don't like school. The problem, as you can guess, is with grades, once you give them as something that children get in exchange for performance, the grades themselves, rather than any internal factors, come to motivate schoolwork. A critical problem, I think, with us parents in our educational system is its failure to sustain and make use of that internal love of learning and exploration that children have when they first get to school. And, frankly, putting a smiley face sticker on a spelling test won't squelch kindergartners love to learn, but why risk it? Why put a gold star on the leaf rubbing that the kindergarten class did just for fun? Why not make just school more intrinsically interesting from the beginning, from the get-go? And that's totally a tall order. But if teachers and parents can figure out how to make learning fun or keep learning fun, they'd never have to promise a reward or offer a bribe, which is how the whole problem with motivation starts in the first place. Okay. A lot of us, I'm guilty of it too, tell kids that they're smart, whether we're teachers or parents. It kind of feels good to do this. Our kids are smart. We want to tell them so, right? And we think if we tell them they're smart, maybe they won't be intimidated by new challenges, or their feelings won't be academic failures. But this is so wrong. 30 years of research has shown that if you tell children they're smart, it doesn't at all inoculate them from underperforming. It might actually. Why? It's a beautiful but simple reason. So if you praise children for intelligence, if you tell them they're smart over and over again, they become to believe that their smartness, that their intelligence is a fixed trait, right? So the problem is this fixed mindset praise takes the control out of children's hands and leaves them with no formula for responding to failure. So a child who has been told that she's smart, when she fails, she believes she's not smart. So when you say to children something like, "Oh, you got a perfect paper, you're so smart," they also hear, "If I don't get a perfect paper, I'm not smart." And once children latch on to this idea that their innate fixed smarts are responsible for successes, they become really reluctant to take on new challenges that don't come with a guarantee of success because failure means they're not smart. And thinking that intelligence like this is a fixed trait, I think, is really troubling, especially for those kids that just sailed through elementary school but then hit middle school and some of their classes require effort. Because if these children believe intelligence is fixed and that nothing can change that, when they start to make mistakes, they conclude, well, they must have been not smart all along. These kids don't try harder or study more diligently because they believe that talent alone creates success without effort. Their poor grades are proof that they can't cut it. It means they're no longer smart. It really only takes a few hits of this brick wall, really, before children can become discouraged and totally not at all be excited about school. And let me talk about recess really briefly, too, because this literature is really interesting and kind of goes into what we were talking about play. Recess in a lot of schools, including my kids' schools, just really has a bad name. I think increasingly schools consider recess just something that's a waste of time because truly it elbows out time that's needed for academics and distracts from the school's primary mission of instruction. At my kids' school, they're older now, but when my kids are in elementary school, the principal banned what I like to refer to as the Holy Trinity: chase, tag, and dodgeball. Just weren't allowed to happen. But the thing is, and what I tried to tell the principal, but it didn't work, is that recess is really good for learning. We know this because it has immediate benefits to attention to classroom tasks, and more importantly, it has long-term academic advantages. And these sorts of findings kind of fly in the face of some educators who make the claim that recess causes disruptive behavior. If you look at the data, you see the exact opposite, that recess deprivation increases the likelihood of behavioral problems. So how does recess boost class performance? It really doesn't have anything to do with kids having to blow off steam. I hear that a lot. Not at all. It has everything to do with attention, which I like to call the holy grail of learning, because for anything to get into your brain, you need to be paying attention to it. If you're not paying attention to it, it really didn't happen. So children benefit from recess breaks, really, because it gives them a moment to kind of rebuild up that attention that's been really kind of hurt through that school day. Children really benefit from breaks away from the cognitively demanding sorts of tasks that are in school, because play serves to reduce the mental interference that builds up during a lot of structured work. The effects are greatest for youngest children, and what's really interesting is that PE classes don't have the same effect, and they don't because a gym class is really as structured as a regular class. It's not free like recess is. So for recess to have these attention benefits, it has to be free. And finally, we talk about homework in just 60 seconds. I think this is an interesting one to talk about because a lot of parents for sure want their kids to have homework, and a lot of folks think that homework is good because, well, you know, obviously it reinforces skills that are learned in school, and that's a good thing, but maybe it really doesn't do any of that. I think homework is one of the best examples of how the ancient brain inside children's heads is really hindered by the demands of formal schooling. Here's what the science tells us. We know that in elementary school that assigning homework to children really doesn't have any benefit, and in fact sometimes it's bad for learning. You really don't see any benefits of homework until kids are in middle school. It's not until kids are in high school that there's really clear, measurable academic benefits, but not if kids are too overloaded. I really find it striking that we have no evidence that there's no academic benefit to elementary school homework, yet a lot of educators or administrators and parents, you know, want it. Teachers feel compelled to assign it. Parents think it's a good thing. I think this is going to be a hard habit to break, but since it's not related to academic achievement, at least until middle school, then why do it? And let me talk about the last thing that's on this slide, just because I think it's fun to squeeze in here. Because so sometimes when I give this talk to parent groups, parents are like, well, what can we do instead of homework? There's loads of answers to this, but my favorite comes from a study that Sandra Hoffer at the University of Michigan did. Her answer would be, make the family dinner. She found in a large study that the single strongest predictor of better achievement scores and fewer behavioral problems for children ages 3 to 12, which is a huge time span, is a family meal together. Family time at meals was a stronger predictor of higher achievement and fewer behavioral problems than time spent at school, time spent doing homework, attending church, playing organized sports, or engaging in activities. So for those people who are like, why not more homework? I think one of the answers is, well, why not more dinner time? So let me, instead of, I know that we're kind of pressed for time, let me take 5 minutes, if that's okay with you, Carly, to kind of finish this off and just talk a little bit about some concluding thoughts, and then maybe we can have some time for questions. This should take just about 5 minutes. Is that good?
That's great.
Awesome. Okay, so let me work through some of the implications of evolutionary thinking for ways that we can think about doing education different. And let me start with thinking, because this is fun. So I think that many of us take thinking for granted. that it's something that we all do automatically and equally well, like breathing or chewing or talking. But the truth is, without special training, we humans really aren't good natural thinkers. We're really gullible, and we believe almost anything that anybody tells us, and it really takes work for us to realize that multiple opinions exist and that those opinions supported by evidence are better than those that are not. So we humans are not naturally good thinkers. So, well, what do we do with this? I think it's exactly why we need school and not just Wikipedia and an internet connection. If we were all naturally good thinkers, naturally skeptical and balanced, schools would be superfluous. So the problem is, in many of our schools, we don't teach much thinking. The reason that we don't is because today's standards movement, again, makes us focus merely on getting children within each grade to learn a bunch of facts each school year. But that's not learning how to think, right? It's learning how to memorize facts and take tests. That's not enough. We need to do that, of course, but it's not enough. We need to get school. We need schools because they are there to help children figure out what to do with these facts, how to think about facts, how to toss them around in their heads and let them marinate, how to do things with those facts, how to discover new facts, how to put old facts together in new ways to do things different. Well, how do we do this? Well, this sort of takes us back, I think, to the beginning of what I had said is we get children to think for themselves by recreating for them the experimental way of learning that was prominent before formal schooling started. Children need to explore new areas as scientists who learns by trial and error rather than being merely a passive recipient of knowledge discovered by someone else. When children learn new things for themselves, they can take what they've learned and apply it widely. So when they learn how to, say ride a bike through trial and error, they can ride any bike, anywhere, anytime. But much of the memorization and fact learning that our children do doesn't transfer to new situations. It's often superficial and, if we're being true to ourselves, limited to the context in which it's learned. And I just have a personal example of this. We all probably have a few, but my favorite one to talk about is when my daughter was in the 3rd grade. She was a rock star at learning her times table. She made a chart, she taped it next to her bed, and she could rattle off anything, between 0 times 0 and 12 times 12. But her rote learning didn't really lead to her understanding of the concept of multiplication. I learned this when we were filling out prize bags for a birthday party. We had 12 girls coming, and I wanted her to put 3 stickers per bag. So I said to her, there are 12 girls coming. We want to give each girl 3 stickers, so how many stickers do we need? Nothing. She had no idea that her knowing 12 times 3 equals 36 meant that we need 36 stickers if we wanted to give 12 girls 3 stickers apiece. So her multiplication skills were limited into the box in which she learned them, right? And we worked on it, of course, and it was all good, but I think this example shows that it's important for children to be able to use the information they've learned outside of the classroom in which it's picked up. And then the last thing that I wanted to talk about, and we tapped on this earlier too, is that not all brains are the same. And we know not all bodies are the same, right? So if you look at this picture, I don't know, say it's a 7th grade class, not every kid looks the same, right? Some are smaller than others. There might be a foot difference between, the tallest and the shortest. Some still have babyish cheeks and shorter legs. Others look more mature. They have longer legs. There might even be some, lip gloss and eyeshadow going on there, maybe some facial hair. I don't know. But just like these bodies are very different, so are the brains inside of these children's heads. Yet school requires that children learn the exact same things, each of them, by the end of the school year. But it seems silly to expect that all their brains grow at the same rate, since it's so clear that their arms, legs, heads, and bellies don't. There's a large literature that demonstrates that brain growth is to a large extent driven by experience. Each child certainly has different experiences, so you would think their brains are massively different. Such individual differences in brain wiring mean that school's expectation that every brain learn the same curriculum at the same rate as every other brain is really baseless. this individual variability, I think, also suggests that we should bring back the customized learning that was common to children for most of human history. Now, individualized learning, it's not a new idea, and tutoring companies like Sylvan really do well because they offer specialized learning tailored to children's needs. But I think maybe the education system should take the lead of these companies and at least think about how they can apply some of this approach. And I get that it would require knocking down much of the current system and envisioning something different. And it certainly would be a challenge for educators to keep track of students' inner educational lives, their aptitudes or motivations or understandings or confusions. But I think that today's mass education experiment, the accompanying insistence that all children do the same things at the same rate, really doesn't make much sense, given that we know that their brains really develop with such profound variability. So to wrap up, I hope that I've demonstrated a bit, at least, the usefulness of an evolutionary perspective for thinking about education in the modern world. I think this framework reminds us that the classroom is, in evolution speak, a species atypical environment. So we shouldn't be surprised that formal schooling is often difficult for children and that not all of them thrive in it. I'm certainly not making any claims that an evolutionary perspective is a cure-all for modern education, but really I'm happy if I've raised some awareness of evolutionary developmental ideas. And if I can persuade educators to at least consider the long-range causes of children's behavior as well as working through the consequences of their novel modern lifestyle. There's a rich research literature relevant to modern education, and much of what goes on in today's classrooms is contrary to scientific research on children's learning. The human brain clearly has been designed by millions of years of evolution to learn through close observation of real phenomena, active experimental investigation, self-correcting problem solving, and a process of guided apprenticeship in meaningful context. But almost none of this happens in the average classroom. In many of our schools, and not all of course, there is focus on drills, memorization, and teaching to the test. Even me, someone in higher education, spends my days lecturing to students and expecting them to reproduce those facts that I just told them on their exams. I think to truly prepare children for life in the modern world, we need to make a more effective connection between evolutionary developmental science and the ways in which we rear and educate children. I think looking at social and cognitive developmental research through an evolutionary lens really kind of gives us some ideas to do this in a way and a place where we can begin this conversation. Let me end it there and see if there are any questions in the few minutes that we have left.
Gabby, this is Carly. First, I'd just like to thank you very much for your presentation. I feel like there are 9,000 other things related to this that I want to cover. And as an educator, as a mom, as somebody who's interested in education policy and entrenched in many ways, I think this is just really a way of thinking that isn't happening in most of our educational settings. Like I said, because we don't have very much time left, we will open the line for people to ask questions. We've got a couple that are coming in on the chat as well. I'd first just like to, thank everyone for attending. We will absolutely be doing more in this series, so make sure that you go to the website and sign up for the newsletter so that we continue to have your information to make sure that you get the invitations in the future. There will be an evaluation sent to you by email. We would really appreciate if you'd fill it out. Give us your thoughtful advice on how this webinar went and future topics, future ideas for how we can structure them and on the later webinars. This is also recorded and will be on the Evolution Institute's website. So please feel free to reference back to it later if you need to, or to share it with others that you think would find this information interesting. So with that, before I just open the lines, we have a couple questions that have come in. I think, so the first is from, excuse me while I get to the right place. Okay, Meredith Martin asked the first, and I think I will just read her question, Dr. Principe, and then,
Okay.
and from that point, open the line. So if you submitted a chat beyond after Meredith, I'm going to ask your question for you, but if you are on there also after that, if you will just chime in once the lines are open to ask your question, I think that would be most helpful so that folks who really need to get out of here right at 1:30 are able to do so. Okay, so Meredith Martin says, thank you for this great talk. I have a quick question. I am a developmental scientist, and I think a lot about the impact of interpersonal violence on children's ability to adjust to the school environment. I totally agree with many of the things that you've said, so this is not a criticism. My question, though, is whether you have any specific suggestions for helping children who are living in families and communities that are in poverty and have virtually no resources for support outside of school. Just the fact that you're speaking to parents who even have the time or thought for how they as parents might support their child's learning is foreign in some communities I've spoken with. In contrast, the parents' view for some is that education occurs at schools. It's the teacher's job. So I'm wondering if you have suggestions for the types of extracurricular activities in lieu of homework, maybe, for children in more risk contexts. And with that, I'll let you answer, and I'm also going to unmute the lines.
I think that is a great question. It's a lot hard to hear, so I'll try to talk over it. Question. In fact, I mean, that could be a particularly interesting, like, whole brown bag lunch question to talk about. I'm not really sure how to answer it in terms of things that can happen outside of school. I absolutely.
I'm sorry to interrupt everyone. Dr. Principe, I'm sorry, but we have a number of background. Dr. Principe?
Yes.
Okay, I apologize. This is one of the problems with opening all the lines. But so I believe everyone is back onto mute. We would ask you again that if you are not answering a question right at that moment, that you have your individual phone on mute or you have your individual line to do so. There's a little green microphone next to your name that you can click to make it muted so that we don't have as much background noise. Thank you.
So obviously this is an evolutionarily novel experience for a lot of us. It's difficult. Yeah, I will say too, it is very difficult for me talking at a computer and not looking at someone in the eyeballs. It's odd to do. But so to answer, or to try to address the question, I think it's something that I could probably address for a couple of hours, and that would be a fun thing to grab a cup of coffee with you about and certainly have a conversation with you about. But I mean, one of the simple, interesting things that I talked about maybe halfway through the talk is just there are experiments that show that simple, typical, everyday experiences are what's important for typical development to happen. So I gave the example of how family dinner time is predictive of all sorts of good stuff over and above something like homework. I think that's true of typical. One of the ways of answering your question is to think about those things that we've done typically over the course of our evolutionary history. So parents who don't have the time or the resources, extra things after school, that's all right. You know, I think a lot of developmentalists make the argument that for typical development to happen, there aren't good reasons to try to enrich it too much. And one of the keys to having typical development happen is to have kids do typical or species typical experiences, you know, at the right time. So things like dinner time, things like free play, things like conversations are all things that are, you know, have that secret sauce in them that make typical development happen. So, I mean, one of the messages that sometimes I try to give if I'm invited into environments where there are low SES families or things like that is just to try to make that case that typical experiences are really often all children need. The extra stuff is all icing, and sometimes that extra stuff actually can hinder development. And there's a huge research literature that that tells that story. And before other folks ask questions, if there are any, I just want to tell everyone, you know, thank you for this opportunity. This was fun to talk about education from this perspective. And if there are folks who would like to continue this conversation by way of email or Skype or anything like that, I'm certainly happy to do that too.
So in light of the issue with having everyone off of mute, perhaps I will go through those who have submitted questions on the chat and unmute you individually. Gabby, you'll just tell us when you just need to go and when you can't take any more questions. But Andrew Hicks, you had the next submitted question. So I'm going to go ahead and take you off of mute if you would like to ask your question. Okay, you are.
Thank you. Yes. I just wanted to support what you said about PE or about recess and about homework, because we've seen that at Center Academy, that it really is beneficial for the kids to follow the approach you described. But I also wanted to ask about cognitive training and working memory training and those sorts of programs from an evolutionary perspective. Is there much hope that we can come up with good programs that will really change the way our brains work or improve those skills?
So my answer to that is I think that we have to be careful. One literature that I didn't talk about that I think that everyone needs to think about before tackling those sorts of questions is if you overstimulate a young brain too soon with too much stimulation, and this is true for humans and it's really true for other animals too, if you give humans experiences that aren't typical for that particular age, funky developmental things can happen. So when we're thinking about interventions or thinking about pedagogies, it's important to think about, well, what is it that the brain expects at this age to happen? A good example is reading, at least in our species. There's evidence that if you try to teach kids to read too soon, that it's not a good thing. It's not a good thing in terms of their literacy or in terms of their motivation for wanting to read. You know, so of course I'm sure some of you know that there's some countries where, for instance, reading isn't even taught until kids are older, until they're 6 or 7 years old, and there's some evidence that literacy is higher in those countries. Whereas if you're an American, you know, in our country, for a lot of preschools, your kid is seen as to some extent an underperformer if they're not reading picture books by the time they get in there, or at least get out of there and move into kindergarten. So I think from an evolutionary perspective, a good place to start is thinking about, well, what's typical at each developmental period? And the answer is different for different developmental periods, of course.
Okay, so next, Marcel Harmon has another question. So Marcel, I am going to unmute you. Here we go. You are unmuted, Marcel.
Can you hear me?
We can hear you now, yes.
Okay. Okay. And actually, it was just a quick comment. I'm a school board member in addition to my day job, and I just wanted to support what you said with respect to individualized learning strategies and the importance of context and learning, and that there are public school districts out here that have started adopting those aspects. We're one of them, and I think there are groups, there are individuals in the public school realm that are recognizing the importance of this and starting to move in that direction. I think probably one of the biggest threats is just lack of adequate funding from the state and support. But I just support what you're doing, keep doing it, and keep getting the message out there.
Yeah, thanks. I mean, you're right on. There's certainly schools that are, absolutely doing some of these things, and I hope that maybe one of the things this sort of framework can give people is an answer to the question why. Why does something like, like Project Lead the Way, like a project-based learning curricula work? Well, that kind of pedagogy works because you could argue from an evolutionary perspective, that's how we've been designed to learn. Why does an individualized approach to learning work? Well, the human brain, has individual differences at different ages. That's why it works. So that's, certainly encouraging to hear that there, our schools, public and private and charter and all sorts of different mixes that are taking some of these things to heed. But I think one of the pieces to remember is that there is certainly some of these changes are not just changes that are good ideas. They certainly are good ideas, but there is research that exists that, maybe in the developmental psychologist lab, but that maybe the educators don't know about. And one of the things that I like to argue for is we need to talk a lot more because it doesn't work if people like me are doing research in my labs and it doesn't make it into the hands of people who are educating children. So the more that we can talk and build off one another, I think it's a good thing. Okay.
Okay, Troy Bell, I think you are the next. You have your hand raised and have also posed a question on the chat. So I'm going to unmute you now. Troy, you're up.
Okay, can you hear me okay?
Yes.
Great. So the question that I posted, I think you essentially addressed in terms of I'm familiar with the research for dinner time and the benefits of that. The unfortunate aspect of that is for the kids that I serve in the Title I charter schools that I operate, most of them are coming from environments where dinner time does not happen, and as much as the parents are encouraged to do so, they don't have the resources or the time in order to execute that. So we look for other ways to create additional brain activity outside of the classroom and in the home environment. And oftentimes, even though I'm opposed to homework because of the research around it, it comes back to essentially that, homework. So those are the challenges that we have. And you mentioned something about getting them to understand that the different experiences is all they need. But again, how do we structure a process by which parents understand how to pursue those experiences and what to do? Because most of our parents are focused on survival. So I'm going to throw that out there.
No, that's...
I have a follow-up question, if you don't mind, after that.
No, I don't mind at all. I think, man, it's a really hard question, and I don't know how to answer it beyond saying, it's an important question to focus on, and maybe one way to answer it is to more often have developmentalists in a room with parents, in a room with teachers and with school administrators, trying to think it out. Because we all come at it from a different perspective. Like it's one thing for a researcher to discover, oh, dinner time has these fantastic effects, but then to hear from an educator, well, that's great, but the population that I serve, that's not going to happen. You know, it's a conversation that it's good for researchers to hear, to think about, well, what other questions can we ask that if they're answered, they will be relevant and helpful to other sorts of populations. So the only way I can even think about answering your question is to think about, to say that is a good conversation for people from multiple specialties to kind of get on and think about, for sure.
Excellent. And let me echo what you said about the value of collaboration. My partner is a professor in the School of Education at Purdue, and just our interaction from the standpoint of the charter schools that I operate and her work at the university has proven mutual benefits on both sides in terms of the way that they teach methods and their approach to pedagogies, and what we're able to leverage from what I learned from them in our schools, of which that kind of is a segue to my second question. One of the platforms that we've had success with in our schools is Arts Infusion as a project-based learning model, and the use of a program called Brainware. And I wanted to ask if, one, if you have any familiarity with that software, and if you have, what your thoughts of that are. And the second question is, we're trying to develop individual learning plans for each of our students, but the difficulty is finding a software platform or student information system that would support that level of detail for all students, not just those students that have IEPs.
Yeah. So the first half of your question, I'm not at all familiar with that software. To try to address the second half of your question, you know, I know of research that has been going on where people have used in-lab, you know, in their own lab developed software to use in experiments on seeing whether or not a software that takes children's performance on, you know, daily or several times a week assessments and figuring out where the strengths and the weaknesses are, and then having that shoot out some kind of answer to teachers about where the focus needs to be. So I know of those things existing in a research environment. I don't know of those things that work well of existing, you know, in schools, but I think that's the way to go. And I think that if we want to move more towards individualized learning, which I think we should do, I think that those are the things that we need to take advantage of to make it work, you know, in 2015. And given the fact that students outnumber teachers by a lot, it makes individualized learning difficult. So any tool that we can use to help us figure out how to do that more efficiently is good. I don't know of any that have actually worked in real settings.
Okay, Dr. Principe, how are you doing on time?
I am good to 2 o'clock, so if there are some lingerers that have more questions, it's fine.
There are. So we'll just keep going. So Ted Howard is the next person who has one. Ted, I'm going to take you off of mute in just a second. Okay, Ted, you're live if you'd like to ask a question.
Thank you. Very sorry I was late, but very much enjoyed what I've heard of the presentation. I align completely with what you're saying. I'm just wondering if you're sort of taking this context into a much broader context, taking it right out there to politicians, to economists, as part of a strategy for the emergence of a new global context of relatedness, cooperation, creativity, and diversity. So, yeah, are you consciously sort of trying to take this out there at the super societal level?
No, I am not consciously trying to do that. But so this is kind of related to your question. I like to use this context to not just think about education, but certainly to think about human development and think about how all of the different contexts that children are in are very different than they've been traditionally. So the school is only one context that children find themselves in. So there are different contexts at different ages. And I think that working through those contexts in this way with these sorts of glasses on and looking at the research literature is really neat. So my interest is more as a developmentalist than really as an educator, and to think about how it is that parents and teachers can think about maybe doing childhood a little bit differently or redesigning childhood just to be more in line with the way that we've been built to develop, at least, you know, keeping that on the back burner and being aware of that. So I'm really interested in more than just education.
If I can jump in this, Jerry, from the Evolution Institute. Ted, this is one of the missions of the Evolution Institute, and we're actually, when we talk about our larger quality of life project and urban initiative, it is policy level items. So feel free to reach out to me and we can have an offline chat about what we're doing and what your interest is. Does anyone hear me?
I do.
Okay.
Poor Ted is just muted again, so here, let me take him off and he can respond. Okay, Ted, you're not muted anymore.
Thank you.
Okay.
Yeah.
Sorry.
Yeah. Sorry. What was? I didn't catch your name in the first instance.
Jerry Miller. I'm with the Evolution Institute. It should be, my email should be on the invite you received.
Right. Okay. I will definitely be in touch then, Jerry. Thank you for that.
Sounds great.
I have been a reasonably active contributor to posts on the Institute's site, so.
Excellent.
Yep.
Okay. It's the same invite holds true to anybody who's still on, by the way.
Well, I think at this point we might want to just open all the lines again, simply because if you are calling in from your phone, I don't even know that you want to ask a question yet. And I saw we had one more hand raised as well, but I think we ought to at least give those folks on the phone a shot. So I'm going to go ahead and unmute everyone in case someone on the phone has a question that they would like to ask. Okay, everyone is unmuted.
So this is Troy Bell again. I just, because I was muted, wanted to follow up on the comment that I made about brainware. Brainware is a cognitive development software that is also being used within the military to help develop fighter pilots and the like. It's also being used to help with language training within the military. But it's seen a lot of good results in our schools. So I'll just throw that out there.
Very cool.
Anyone else have a question? Okay, I think then we have reached our conclusion. Thank you again to Dr. Principe and to everyone who has called in and participated. Again, you can find this, a recording of this webinar on the website, and we look forward to hearing from you at the next one. Goodbye, everyone.
Thank you very much.
Thank you.